Ugh! Why do all my mouthpieces smell so terrible?
Hey, watch where you're throwing these things. This stuff's not stable.
Sorry, it's just my mouthpiece. It smells like my grandma's dirty silverware.
Let me see. Yeah, that smells like my grandma's dirty silverware. It's the oxidation of your mouthpiece.
Oxidation? Like when an apple turns brown?
Yes, exactly. Oxidation of metals usually takes a long time, though. Have you not been practicing all summer?
Well, at least once, but how does that even work? How does a mouthpiece become oxidized? Maybe I was breathing on it too much from all that practicing?
Not exactly. This is a redox reaction, or an oxidation and reduction reaction. Oxidation is the loss of electrons, reduction is the gaining of electrons. Basically, that means that this reaction involves the loss or gain of electrons. Let me explain. This is a formula for what happens to your mouthpiece.
Whoa, I have no idea what that means. I remember all the atoms from chemistry class, but I don't understand the numbers.
Each atom has what's called an oxidation state. The oxidation state is a hypothetical charge of an atom.
Hypothetical charge?
It's not really a charge, just an imaginary charge, assuming all the bonds are ionic, or that there is an attraction between two oppositely charged atoms. The electron belongs to the more electronegative atom. The free elements oxygen and silver are not bound to any other atoms, and both would have a hypothetical charge of 0, so they have an oxidation state of 0. In the hydrogen sulfide, the sulfur is more electronegative. Thus, we assign the hydrogen electron to the sulfur. The hydrogen will have an oxidation state of +1, and the sulfur will have an oxidation state of -2. On the other side, with the products, silver, being a metal, attracts the electron less strongly than the sulfur. The sulfur has a -2 oxidation state, and therefore silver would now have a +1 oxidation state. Therefore, the silver's oxidation state changed from 0 to +1, so it lost an electron, and we should say it has been oxidized. Oxygen went from a 0 oxidation state to a -2 oxidation state, and therefore it has gained 2 electrons, and we would say it has been reduced.
Okay, so my silver mouthpiece was oxidized by the oxygen. Well, that's interesting and all, but how can I fix it?
That's an easy one. To fix your mouthpiece, all you have to do is go to the chemistry building. This is simple. All we have to do is perform a redox reaction to get rid of the sulfide. For that, all we need is baking soda, aluminum foil, and a pan of hot water.
Aluminum foil, a pan, and baking soda? What are we doing? Turning my mouthpiece into a muffin?
Just get over here. Now, here's a formula that shows a reaction taking place.
Okay, so the oxidation state of the aluminum is 0, just like the oxygen and silver before.
That's correct. Aluminum has an oxidation state of 0. Now, what about the rest?
Well, we said earlier that in silver 2 sulfide, silver has an oxidation state of +1, and sulfur has an oxidation state of -2. In the products, silver is not bound to any other types of atoms and has an oxidation state of 0. Therefore, silver went from +1 to 0 by gaining an electron, and so it was reduced. Finally, sulfur has an oxidation state of -2, and therefore, to balance the hypothetical charges, aluminum should have an oxidation state of +3. Therefore, aluminum goes from 0 to +3 and is oxidized.
Exactly. In the first reaction, the silver was oxidized. In our second reaction, silver was reduced. And most importantly, now you have a clean mouthpiece. In the first reaction, the oxygen was the oxidizing agent because oxygen caused silver to be oxidized.
And therefore, silver would be the reducing agent because it caused O2 to be reduced?
Exactly. Now, what is the oxidizing agent and reducing agent in the second reaction?
Well, silver gets reduced because it gains electrons from aluminum. Therefore, aluminum is the reducing agent and silver is the oxidizing agent.
I think it's time for us to enroll you in a chemistry class.
Well, maybe, but I have to ask, what happened to that box that you were carrying before on the field?
What Uh-oh.
Wow, it looks like chemistry is a blast.
Very funny. However, this is another example of a redox reaction. In fact, when you think of a redox reaction, you often think of an exothermic reaction, meaning as the reaction takes place, heat is produced and released into the surrounding universe.
Wait, so you're telling me the same reaction that caused my mouthpiece to tarnish caused that explosion?
Well, remember, a redox reaction is the exchange of electrons. So in a sense, it is the same chemistry, but not the same reactants and products. Here's an example of a combustion reaction of natural gas, which is mostly methane.
Okay, let me try this one out. So hydrogen has a +1 oxidation state before and after the reaction. Therefore, carbon has a -4 oxidation state before the reaction. In CO2, the two oxygens would have a -2 oxidation state. Therefore, the carbon will have a +4 oxidation state in the products, and so carbon was oxidized. Oxygen in the reactants has a 0 oxidation state, but in the products it has a -2 oxidation state in both H2O and CO2, and therefore it was reduced. Finally, because carbon was oxidized by oxygen, oxygen is the oxidizing agent. And since oxygen was reduced by carbon, then the carbon is the reducing agent.
I think it's about time for you to join the chemistry department.
I could never. Music is cool. But now, it's your turn for a lesson. Yeah, maybe just stick to chemistry?
Don't worry, music is cool, but chemistry rules!